Good morning, good afternoon, and good evening. We hope you're enjoying the virtual event so far. Welcome to Shop Talk Live and to this breakout session. Let's talk shaping the future of manufacturing. It's great to see so many of you joining us from all over the world. We're excited to share valuable insights with you over the next 40 minutes or so. I'm Robin Tyndall, and Robin Henschel and I will be the speakers for this breakout session. Before we dive into the content today, I wanted to remind you that the breakout session is designed to be interactive, engaging, and most importantly, informative. The best sessions are those where your questions get answered and your concerns are addressed. So we encourage you to participate actively throughout the session. And we have multiple ways to ensure your questions get answered. Some of you submitted insightful questions during the registration, which helped shape today's content. So thank you for doing that. And in addition, please ask questions throughout the chat by using the chat feature on the breakout session. Our dedicated team of assistants will monitor that chat, and our goal is to cover as many queries as possible, though if we don't get to all of them, rest assured that we will follow up afterwards. Again, a warm welcome to Let's Talk Shaping the Future of Manufacturing. Get ready to engage and make this session informative and interactive for everyone. So in our visits and conversations with customers, both Robin and I have heard that they're interested in being more sustainable and more profitable. Maybe this sounds like you. Maybe you're doing well in one of these categories, but not the other. Or maybe you're doing great. Maybe you're already sustainable and already profitable, but you'd still like to do better in both. Well, the good news is that your challenge is our challenge. We have a triple bottom line mission, and we consider it part of that mission to enrich our communities and the environment. And we consider it a critical success factor that we reduce the environmental impact of everything we do. And everything we do includes you, our customers. So we've assessed the life cycle impacts of our products, and it turns out that the number one impact is the scrap that's created during our customers' cutting processes. And the number two impact, but it's a distant second place, is the energy that you, our customers, use while cutting. So yes, that's correct. The environmental impacts of scrap created when you cut your raw materials is a bigger impact to the environment than all of Hypertherm's logistics, operations, energy use, and travel. So scrap costs you a lot of money. We recognize that, and I'll touch on that in a moment, but it costs the environment a lot too. And that's really all about the life cycle impacts of the material. Whether it's metal or something else, there is embodied carbon. And that's because of all the processes that it takes to mine, manufacture, and transport that material. So even though we assume that it's 100% recycled at the end of its life when it is scrap, which is quite easy to do when it's metal, it is still the biggest driver of environmental impact. So, as I just mentioned, that second place impact is energy use, and that's part of our shared challenge, certainly. I'm pretty sure that you all understand this really well already because you've been paying your energy bills every month. So right now I'm going to focus on explaining why scrap is such an amazing improvement opportunity. So there's the cost of scrap initially in the form of the raw material when you buy it. So that cost is pretty obvious. But there are also a lot of hidden costs with scrap. Of course, you need labor to move it away. It might cause a time delay in your process. It also might need special equipment, handling equipment or a crane in order to move it. And anytime there's a non-standard process for managing your remnants, there's going to be wasted time. Whether you're storing your remnants really nicely, like this picture on the right, or whether your scrap pile is a little bit more messy, like the picture on the left, the fact is that is costing you overhead. It takes up space, and that space could often be used for something more productive that could generate profits. So that's an opportunity cost. So in our data that we've looked at from millions of nests over thousands of customers, what we've seen is that 42% of nests, which is quite a lot, achieve less than 70% utilization. So we've realized that that's a problem. And to understand why that happens and what we can do about it, I've just drawn this simple diagram. So first you have raw materials and you pay a certain price for those. And what you do with those raw materials is you put them through your process. Some think of it as a black box. Part of that process is your hypertherm products that you might be using to cut or process that material. But it's also your ingenuity, your designs, your innovations, your process. It's your revenue generating machine. It's like your value creation magic. So yes, your process creates value because you're generating revenue. You're creating much more value than what you put into it. But at the same time, you're in a way destroying value because you're making scrap. Scrap is pure waste. You're taking a raw material that you paid for, you're adding labor that you paid for, and you're getting something worth much, much less, and that is scrap. So really, that's a value destroying process. So let's walk through an example of how you might improve. If you have throughput of 1 million pounds per year of material and you're at 70% utilization, you might have a certain revenue there that we've based on certain assumptions. And if you increase that utilization to 75%, your revenue could increase by 40%. And if you start out even worse at 60% utilization and move to 65, your revenue is going to increase even more. So let's look at another couple of examples here. This example is from a real customer that was a shipyard in the EMEA region, and it was looking at just their annual usage of 12 millimeter thick mild steel. And you can see here what their throughput was in kilograms and what their raw material spend was. And they initiated several projects to increase their utilization by 4%. So they were starting out at 78% and managed to get to 82%. So 4 percentage points increase. So you can see that the weight of scrap that they produced went down, but what they really wanted to see was what that was going to change in terms of their profitability. So you can see there that their profit plus their scrap revenue, and scrap should not be thought of as revenue, from before and after increased by $330,000 or 22%. So the reason that that happens is because from that diagram I showed earlier, where you're either creating value or destroying value and moving in the direction of creating more value through higher utilization, is you're seeing a logarithmic curve. And what that means is for really small gains in the input, you're seeing huge gains in the output, and you're seeing them early. So that's why those small percentage point increases should not be underestimated in terms of the power that they have to increase your profitability. This is just another example where we put in real numbers from a real customer and saw what their earnings increases would be given small increases in their plate utilization. And another way of looking at that is just with a different type of graph where you can see their baseline utilization of 80%. This was under assumptions of 13 millimeter thick mild steel and a 6% profit margin, and how adding 1, 3, or 5% to their utilization could have such a dramatic impact on their profitability. And so I also wanted to just take a moment to explain and put into context what that means from an environmental stewardship standpoint. So I ran this example again with 20 millimeter thick mild steel and running that on a Hypertherm HPR 260 XD heavy industrial system, 2 8-hour shifts a day all year. And what the impacts from an environmental perspective and a carbon perspective would be from doing that is equivalent to 1.5 million miles driven by an average gas-powered car. That's equivalent carbon emissions. And said another way, it's equivalent to burning for power generation 663,000 pounds of coal. So in that first example from the shipyard, if that scrap is reduced by 22%, that's equivalent to avoiding emissions from over 334,000 miles driven. And it's also equivalent to the amount of carbon dioxide equivalent emissions that could be sequestered by 156 acres of forest. So you can see that that's a really big impact. So not only are you rewarding yourself by increasing your profitability, you're doing a good turn to the planet as well. So with that, I'm going to hand the presentation over to Robin Henschel, and he will review some of the techniques you can use to reduce your environmental impacts and increase your profits.
Okay, thank you, Robin, and you showed some really interesting and big numbers there. And I now just hope that I can keep up with these impressive numbers during my presentation. So what can we do from our software, from our ProNest software with measuring the utilization? So in our ProNest database, we have a bunch of data stored, and among the available data there, we have, of course, information on the blades that we have used to cut all of the jobs in that we have created with ProNest. Among this data is the material length, width, thickness, and all of these. Here we see a short or a screenshot on the export of the data into our Excel file, and you see a lot of numbers in there. And even as I really like numbers, it is hard to get any clue what is going on in there. What am I doing? So what I have seen at a lot of customers that I have visited, they have such a Power BI dashboards, or it's a different software dashboards showing their key figures of their production. And they can easily include these exports from our database into these dashboards to show the utilization. Here we now have an example with the data from my demo system. You see my utilization is not always at the level it should be. This is now all the nests that I have done in the last 24 months. We see the difference in the utilizations, and we can also break this down into different materials. Here now everything on a mild steel 10 millimeter or mild steel 6 millimeter. And of course, when you are measuring your utilization and you want to increase your utilization, you should just see one direction of the graph, and this is going up, in the best case, up to 100%. Can we always do this? I don't think so, but this is our goal. Before we now dive into the big topic, utilization, Robin already mentioned that there is a second topic. This is the energy consumption, which also has an impact on your carbon footprint. And now let's start with this one. First, start with the easy stuff. So when we start thinking about the carbon footprint, we should think about reducing the energy that we are using for the cutting process. And this starts in ProNest right at the beginning when we start to select the cutting class for the job that we would like to do. Of course, it has a big impact on your energy consumption. If you're using a 130 M cutting class, a 220 or even a 300 M cutting class, the energy consumption will be way different. Of course, when we go for a lower amperage, also our cutting speed will be lower, but also our quality is a bit better. You could now say, okay, but I need the speed because my production is full. I need to cut as fast as possible. Well, even when you go down on your amperage, we have some ways to increase or to decrease the production time of your nests. One of these things that we can use is our collision avoidance module. I know the name sounds a little bit different. The main thing of the collision avoidance module is to avoid collisions of the torch with parts that may tip up during the cutting. To achieve this goal, ProNest is recreating and recalculating every single cutting pass, looking at the torch races and optimizing everything. Due to this optimization, on a simple nest like this one, without the collision avoidance, we have a production time, let's say 1 hour and 33 minutes. And when we now just activate the collision avoidance module in ProNest, then we go down in the production time to 1 hour and let's call it 3 minutes. So it's a reduction of 33% of production time. This is also a saving of energy. And when we can now combine this with a different cutting class, then okay, our saving production time might not be that much, but we are saving the energy on the cutting class. There's also something that we can do in addition to this to reduce the production time. If the quality of the parts allow, we can use the common line cutting when it's possible. When in this nest we now activate the common line cutting function, we see here these parts all now have joined sides. Here it's just a small side, here it's a little bit more. We already see when we now compare this with the original nest that we are using less material for the same amount of parts. But what is the impact, the real impact? Without the common line cutting, as said before, we have a production time of 1 hour and 3 minutes, and we are using let's say 58% of this blade. With the common line cutting, we are now going down to a production time of 59 minutes. So again, 3 minutes saved. And we are just using 54% of the blade. So we have already increased our utilization of this blade by 3%. So we are now coming from the energy savings to the increased utilization on the blade. The common line cutting is just a small tool that we can use to increase the utilization of the blade. And as said, the quality, the cut quality, you must be aware that on the common line cutting you have one good and one bad side. This is the physics of the plasma. Another thing that we can use to increase the blade utilization is the blade saver. The blade saver you can use together with our Hypertherm XPR power source. And with the blade saver, we are utilizing a special lead-in to reduce the lead-in size. Here we have an example of a standard lead-in on, I think this was a 15 millimeter mild steel. This is what you have on the standard settings, the separation between the parts with the standard leads. When we now just activate the blade saver, we see that the dimension or that the size of the skeleton is way smaller. And of course, this is immediately increasing our utilization on the blade. One thing to mention on the blade saver is that this is only available with the XPR power source and on mild steel on a thickness between 12 millimeter and 30 millimeter thickness. If you want to use the blade saver for a nest, how to do it? Well, it's quite easy. When you are selecting the cutting class, just look for a cutting class where the blade saver is in the name of the cutting class, and then all of the settings will be applied automatically. So now let's go to a real example. We have now selected the blade saver cutting class. ProNest has enabled now the special lead that we have for the blade saver. We do here a moving piercing, so we lower the torch while we are doing the piercing. This helps us to stabilize the arc in this short lead. When we now do a nest of these rectangular parts, this is a thickness of 50 millimeter. The blade dimension is 2.4 by 1.2 meters. With the standard cutting class, we have here now 34 parts nested on this single blade. When we look at this one now, we say, yes, it's quite a good nest. There is not much room to add any additional part, right? Well, when we now activate the blade saver cutting class, it looks like this. same parts, same plate dimensions, but we have 4 additional parts on this plate. Instead of 34 parts, we have now 38 parts. We can compare these two now, and now let's have a look at the utilization. Without the plate saver, we are at 83% of utilization. With the plate saver, we are at 90% of the utilization. So it's a big increase of 7%. Of course, I have to mention that these 7%, you will not get these all of the time. When you are just cutting these kind of rectangular parts, you will see them. If you are also cutting round parts, for example, the saving will not be that high. And we have measured an average of an increase of 3% on a nest, just depending on the parts that you are cutting. Another thing that I like to mention on the plate saver, as we are doing a moving piercing for the plate saver, we will create a big splash of material during the piercing. ProNest is indicating in which direction this splash is going. And please do not look at the size of this triangle. This is just a symbol. The real splash might be way bigger. In case that you have an operator standing here, you can define in ProNest that there should be no splash to one or to up to 3 sides of the plate. Then ProNest will just direct the splash into the sides that we allow. Okay, so now we do not always have so many parts to fill a whole plate with it. Sometimes we just create a nest like this. And now what should we do with the rest? In ProNest, we can easily create a crop cutting to this plate. And so ProNest will cut off the rest of the plate. We can define in the settings on how this crop cut should look like. Should it just be a straight cut? Should it be a L-shaped cut or a profile cut like we see it here? And also we can define the minimum width and length of a remnant. So in my settings, I said something like this is just too small. I don't want to have this in my stock as I won't be able to use it, but this can be set in the settings. In these remnants that we create here can go into the plate inventory within ProNest. And we can store all of the remnants in there with their actual shape for later usage. So if you are cutting a lot of nests each and every day, and at one point your plate inventory might look like mine here, a lot of remnants in there. And now what remnant is the best to use for the nest that you are cutting at the moment? Well, we have a module called Nesting System Optimization that can help you with this. The Nesting System Optimization module is a quite powerful module, and so we have a bunch of settings that we need to do. Now let's just go quickly over the settings. One of the settings is what nesting strategies should be tried for during the run of the module. Should this module just look for one plate size for all of the nests in this job, or should it always look for the best plate for each and every nest within this job? And now one of the interesting things is we can also say to this module that it should include the material costs into its calculations. So we can say a remnant from our side is always cheaper to use as a new plate, as we want to have a turnover in our stock, and we don't want to necessarily use a new plate. We want first to use our remnants that we have on stock. As Robin said before, there's nothing more expensive as having remnants on stock that are not used. This scrap that is just laying around. When we have done all of these settings, ProNest will start with running through all of the possible plates with all of the strategies that we have selected. We see here a total of 125 trials are done. At the moment, it is here at trial number 3, and the best utilization found is at 45%. A little bit later in the process, we are at 72.5%, and this will now go until it has done each and every trial, and in the end, it will come up with the solution. This remnant now here was the best choice for these parts that needed to be nested. So this module is a great way to use your remnants that you have on stock. But wouldn't it be better if we would not have any remnant? We would save the energy for the crop cutting and the remnant handling. Okay, maybe these savings are not more as a water drop on a hot stone, but when we think about it, even the Grand Canyon just exists because of a single water drop which started the process. So let's think about what could we do to not even create a remnant. We have a module called Production Manager. This shows you a lot of data on all of the nests that you have already cut. So for example, if it's in production at the moment, is it pending, or is it already a finished cut? It also gives you information on the material that is used, on the plate side, and on the available free space on this plate. If we now have, for example, some parts that we need to nest on a mild steel 10 millimeter, we can type this into the search bar of this nest view in the Production Manager, and the Production Manager will show us all available nests for a mild steel with 10 millimeters. We now can have a look at the utilization or at the available space on the plate. We see here we now have 60% of space available. We can have a look on how this nest looks like. We say, yes, I want to add my parts to this nest. I go into the nest. I look up which ProNest job this one is. I remove the output from the plates to cut so that no operator can now cut this job while I am modifying it. I go now to ProNest, modify my job, and now my PowerPoint didn't want to move to the next slide. And now we have modified everything, and we see in the end, when we look again, free space 3%, 1%, 1%. And so we have saved now a lot of utilization or a lot of plates in our production without even creating a remnant anymore. If the 1% is really realistic to achieve on each and every nest, I don't think so, but we need high goals. Okay, so this is now the part from my ProNest software, and now I hand it over to Robin again for a quick summary.
Great, thanks, Robin. So in conclusion, I hope that you've learned from this session that you have immense power. So first of all, you have the power to understand that scrap is not revenue. It's value destroying, and it also impacts the environment. But you have the power of your Hypertherm products, and specifically ProNest. You have the power to make the change to be more sustainable and more profitable than you are today. So I'm going to hand it back to Robin now to go through some of the Q&A that has come through.
Okay, thank you, Robin. So we have now finished the main part of our presentations. Now let us go to our Q&A part here. We have been receiving some questions during the registration process. We will now handle these questions. All other questions should already have been answered in the chat by our colleagues. If there are still some pending questions, we will come back to you with the answer a little bit later. Okay, so the first question, it's one for me. Can ProNest work with other cutting processes as plasma? Yes. We know that Hypertherm is mainly known for plasma cutting, but our ProNest software is not just solely for plasma cutting. We can also do oxy-fuel cutting. We can do plasma cutting. We can do water jet cutting. We can do laser cutting. It's all not a big deal for us. We also have done some knife cutting already and other things. So yes, definitely, we can do other cutting processes as just plasma. For more detailed answer, please just send an email to one of us. We will go through how you can contact us a little bit later. Okay, second question, again for me, that's nice. Can ProNest work with non-Hypertherm equipment? Yes, of course. And my colleagues sometimes hate me for this when I say, for me, it does not matter if this is a Hypertherm power source or if this is a laser from some competitor. With ProNest, we are not bound to the Hypertherm equipment. We can work with any CNC controller. We can work with any plasma power source, with any laser. The only requirement that we have when it comes to CNC controllers is that they accept a human readable code. There are some controllers out there, especially they are coming a lot of times from China. They accept just a binary file. And we cannot reproduce these binary files because we do not know what is in there. But also for these days, a workaround, most of them accept a DXF file. So we do the nesting in ProNest, output the whole nest as a DXF file, and then hand it over to these controllers. Okay, and I think the last question, this one is for you, Robin.
Yes, you're right. So someone asked, as a customer, is that scrap that is created by you, the customer, during your cutting process, is that considered a scope 1, 2, or 3 in terms of its carbon emissions? So the answer is, for you, the customer, that is considered scope 3. It's also considered part of Hypertherm's scope 3 carbon emissions. So in that way, we're kind of jointly responsible for that. In terms of the energy use, that second place environmental impact, the energy that you use when you go through any cutting process in your factory, that is considered a scope 2 carbon emission for you. So that's all the questions for now. Back to you, Robin.
Okay, so yeah, all of the questions are answered. So the last thing to do is we would like to say thank you for joining our session today. And before we finally close our breakout room now, please consider or please have a look at our area here. We have here a get in touch field. You can use this to send us questions, ask for demos or anything else. And please also explore all of the other areas that we have in here. There's a lot of content to discover, and I think you will, or we think you will really enjoy this one. Okay, so now we are at the end of our session. The only thing left is to say thank you for your attendance, and we hope to be in touch with you soon.
Thank you.